We are back to discuss respiration by Nicholas Atwine. You can subscribe to my YouTube. You will also find there Atwine Nicholas. We are continuing with the respiration, and we're actually going to look at composition of inspired air and expired air, air intake and air output. So we are moving. We are looking at the type of air. Then we have inspired air we put in. We have the type of air, and the air we put in, air we put out. If we take a case of oxygen, we inhale or we inspire 21%. But after we shall expire, we shall take out 16%. Where does the rest go? Are you noticing the decrease or increase? Intake is 21, then outtake is 16. There is reduction. Why does this reduction occur? Then when we go to carbon dioxide, we have 0.03 intake. Then we expire 4%. There is increase. Inspired was 0.03. Now we are not seeing increase of 4%, of increase of 3.97 almost. Then nitrogen, we inspire 79, then we also expire 79. Water vapor, we inspire less and expire more. Why? The changes stem on respiration. Because during respiration, food is broken down by oxygen. When we break food, meaning part of oxygen here is used to break down food. That's why it reduces from 21 to 16. Breaking down food, oxidation of food to release energy, carbon dioxide and water vapor. There is oxidation, part of oxygen is added to food. Therefore, it will have to reduce. So why is it that it reduces? Part of oxygen is used during respiration. And why is it that carbon dioxide increases? Part of it is produced during respiration. Because we have seen that oxidation of food to release carbon dioxide, energy, and water vapor. So carbon dioxide will be released. That's why there is increase. How about nitrogen? We are putting in 79, we take out 79. Why? It's because the reason is just one. No body process uses nitrogen. Why is it that water vapor increases? It's because even during the process of respiration, part of water vapor will be produced. That's why it increases. What happens when we are breathing in? The volume of the chest and lungs will increase. When you breathe in, check. When you try to breathe in, we shall see the volume of chest and lungs do increase. Then diaphragm and intercostal muscles will contract. The diaphragm will, that's why you see your chest is like moving up, will have to contract. Ribs move upwards and outwards. The chest will move upwards, therefore the ribs will move upwards and outwards to increase the surface area. Then the lungs inside will increase in volume. What happens when we are breathing out? It's the reverse of what we have seen up. The volume of the chest and lungs will reduce or will decrease. Diaphragm and intercostal muscles will relax this time. Then ribs will move downwards and inwards. When we are breathing in, it goes upwards and outwards. But when we are breathing out, it goes downwards and inwards. Then the lungs will have to reduce the volume. We have to look at the diseases which affect the respiratory system. We have tuberculosis. We have influenza. This one is immunizable. This one is immunizable. This one is immunizable. Lung cancer is not immunizable. Emphysema is not. Bronchitis is not. Pneumonia is immunizable. Whooping cough is immunizable. Meaning so many questions can be asked here. Identify immunizable diseases which affect respiratory. You pick whooping cough, pick pneumonia, pick tuberculosis, influenza, and if Diphtheria, D-I-P-H. Some miss this letter H. Then others, we have emphysema. This one is facilitated by smoking, even lung cancer. Even bronchitis is facilitated by smoking. We have asthma, this hereditary disease. So those are some of the diseases. We have those which can move from infected person to a healthy person. Infectious respiratory diseases, or they can say communicable infectious diseases. We have tuberculosis. This one is caused by bacteria. Diphtheria, also caused by bacteria. Whooping cough, also caused by bacteria. Pneumonia, caused by virus. Influenza, caused by virus. All of these are immunizable diseases. We have those which can't spread from one person, from a sick person to healthy. We have asthma. I've said that this is a hereditary disease. We have lung cancer, facilitated by smoking, emphysema, bronchitis. This one, or lung cancer, emphysema, and bronchitis are all caused by smoking. How can we improve the efficiency of the system if we want our respiratory system to work very well? How do we deal with it? We should avoid smoking, as smoking causes emphysema, lung cancer, and the rest. Then we need to have regular physical exercises. Good feeding is essential, or feeding on balanced diet. It is essential, and it cross-cuts to almost all systems. Then eat food with low fat. We need not eat too much fats, because accumulation of fats may lead to obesity. We keep away from dusty places. Disorders of the respiratory. Disorders. Remember, disorder is not a disease. Choking. This occurs when food tries to enter the respiratory system through windpipe. Then we have hiccup. It's involuntary action, whereby you are like, you wish to vomit, but you are not vomiting. Hiccup. Involuntary movement of diaphragm, hiccup. Then we have sneezing. Respiration in relation to food and oxygen. We are going to look at the respiration that involves oxygen added into food, oxidation of food. Respiration is a chemical burning of food. Food is burnt chemically in the process we call respiration. And what helps in burning? When you are trying to cook, you must have source of heat. So where is the source? We are having oxygen as a facilitator, and this oxygen will burn food, and at the end we shall have to release energy. Start the use of food, start the use of oxygen in the body. The use of oxygen in the body is not breathing. It's not. The role of oxygen in the body is to actually help the body release energy. That's the role of oxygen, not breathing. So water vapor and carbon dioxide are released as byproducts. So byproducts of respiration, we have seen water vapor and carbon dioxide. And sometimes they ask waste products removed from the body by lungs. So it is water vapor and carbon dioxide. Where does it occur? It occurs in living body cells, not dead ones. Then we have, this is the summary, we have food. When we add the oxygen, we say we have oxidized food. Oxidation has occurred. When oxidation occurs, we shall see the body generating carbon dioxide, we shall see the body generating water vapor, and energy at the end. So energy will help us to perform different tasks. We do have different types of respiration, whereby the first one is aerobic. Aerobic respiration, this is the type of respiration which involves the use of oxygen to burn down food and release energy. So when you add oxygen into food, into starch particularly, we shall say that aerobic respiration has occurred. But we have another respiration where oxygen is not a necessity. We can have respiration occur minus the presence of oxygen. So anaerobic is the type of respiration that occurs in the absence of oxygen. And food is burnt down partially. There is partial breakdown of food. Where does it occur? When does it occur? When you are performing physical exercises and food and the body uses energy generated from starch, there reaches a time when that food generated from starch is almost used up. The moment it is used up, the body will start converting fats. Those fats will be converted to make the body generate more energy such that the body performs the task. So it produces lactic acid in animals, and when you don't have enough fats in the body, there will be generation of lactic acid. Or when starch is no longer in the body, then the body is like, let me start converting fats. We shall have formation, we shall have accumulation of lactic acid in muscles. That's why sometimes you will feel some pain in muscles. Then in animals, we shall have formation of alcohol, most of the times during fermentation when there is presence of yeast. Then it occurs in muscles during exercise. Anaerobic respiration occurs in muscles. We shall have the body converting fats to generate energy when performing exercises. Thank you so much for your attention. Thank you so much for listening.